So, guys, today I will teach you how you can extract the expression data. By expression data, I mean how you can get the values of the expression for gene of your interest. So, here in Google, we write here, let's say, EBI expression. This is EBI Expression Atlas, and this is one of the very well-known site for expression for determining the expression of especially genes in the mammalian species. So this is here is the web page for expression atlas. In the query sequence we will put the uh, gene IDs of the genes for whose gene whose expression we want to determine. So here is, for instance, these are our gene IDs. You can add, add the IDs of maximum 100 genes at one time, and not more than that. This here, and our species is mouse, plus, and here we are interested in the adult tissues. Adult tissues. So we put search here. So here is the result. Now we here get this. This is one of the very well known. Uh, these are different actually experiments which has been designed by different scientists. So we will focus on this experiment because it contains the maximum number of tissues which have been studied in mouse. We click it. Okay, we don't want more specific. You can take it away. More specific. And so out of 8 genes, only in 2 genes the expression is available. Anyway, we can uh, go for the downloads, all data. So this is saved here. We open it. Uh, we can open it. Okay, we can go to the. Uh, we can open Excel here. Now this is not because in the columns we will convert it into the column. We get next, next, and finish. So here is the data. Now you can see these are the different tissues, and these are the genes, and this is expression. These genes are it looks that these genes are showing very low expression. So we will have to filter the data. I will let you know how we can do it. So as we consider those genes as being expressed whose values of expression is 1, so all the genes whose expression is lower than 1 we will consider it equal to 0. We will change it to 0, and all the genes whose expression is 1 or more than 1 we will change the value to 1, because at the end of the day, a 1 or more than 1, it is the same in terms of expression, because we consider them being expressed and we want to see in how many tissues a gene is being expressed. So we have to do this little bit of what we should say, a manipulation of the, or not manipulation, I mean, little bit of filtering of data just for the calculation purpose. And so for filtering purpose, we select all these genes, all these expression of genes, all the tissues I mean, and then we will go to Control H and find, well, we can find 0.1 and replace it with 0. Replace all, okay, and 0.2 replace with 0. Replace all, okay. 0.3 replaces with 0, and so on and so forth until you reach to 0.9. For 0.4, 0.5, 0.6, 0.7, 0.8, and 0.9. Fine. Now that's fine. And any value which is 1 or more than 1, we keep it as 1, because we want to see in how many tissues it's being expressed. And any value which is 1 or more than 1, we will replace it with 1, because whether it's 1 or 2 or 3, it means that it's being expressed. So value which is 2, it will be 1, 3, 4. I think there is no one, but you have to do it till all the values which are more than 1 or 1, they are equivalent, they show as 1. Fine. So in this way you will do it until you see that each and every value becomes 1. And now we will see it. We can do it like this. This is let me delete these rows, we don't need them. Fine. Now we can increase another column here, and we can write it number of tissues. Fine. And in this way, uh, let's see, we like this, and we can sum. So sum, we go from here to here. Fine. And we enter it. So there is a no tissues being expressed, and a no tissues being expressed. Fine. So in this way, you can tell that this gene is being expressed in no tissues. But because I will be giving you many genes, so you will ultimately see that in many genes will be showing much higher expression levels. Fine. So at the end, now we have the expression values for each of our genes in all these tissues, in ovaries, in pancreas, in pituitary gland, in prostate gland, and in spinal cord, in spleen, etc. And thank you very much.